At the end of a reaction, sometimes we have a product that's not very soluble in a solvent, say water, and we want to extract it into a solvent in which it's more soluble, like an organic solvent. Two of our common solvents in here are dichloromethane for an organic solvent and diethyl ether. They're really different solvents. Dichloromethane is more dense than water and would form a layer underneath the water. If we're using diethyl ether, its density is less than water and it would form a layer on top of water. So you have to really pay attention as to which is your organic layer. It depends on the organic solvent we're using. All right, so we need what's called a separatory funnel. Okay, here it is. If you look at it, this is a stopcock. When that little handle is turned straight up and down as I have it now, there's a hole, the holes inside are lined up, and liquid can pass through. So it's closed when it's 90 degrees, like so. Okay. Now it stinks to hold this, okay? And so what we're gonna do, we're gonna affix it to a stand in the hood. Ring clamps are really helpful. All right. The first thing you want to do though is check and see if the ring clamp will hold your separatory funnel. And this first one I chose is too big, so that's not going to be useful. You have two options at this point. You can grab and look for a smaller ring, and hopefully that'll fit. So if you're lucky, you can find a smaller one, and it does. That's the most convenient situation. Or you can use that original big ring and a cork ring. So what helps here is, if we were to clamp this on, put the cork ring, and then try the separatory funnel, and that will work. Okay? But we'll just use a smaller ring because it is easier if you can find one. All right. So we'll clamp that ring. We're going to put the separatory funnel in it. Make sure it's closed. That is a very key part of this. Look for a glass stopper in your drawer. Okay, it should fit it perfectly. The ground glass pieces should be a perfect fit. And if they are not, ask your instructor to swap it out and get you one that fits. Now before we begin the extractions, we want to make sure that there's something underneath that vessel just in case you've accidentally left this open or there's a leak, so that if anything goes through the top and the bottom, you're catching it. All right, now what we have here is a reaction mixture. You can see it's kind of not fully dissolved. It's in water. So what we're going to do is we're going to extract this organic compound from the water into dichloromethane. So I'm going to put that in a cork ring to set that down. Now the procedure calls for 10 milliliters of dichloromethane. You don't have to measure this exactly to 10.0 milliliters when it's a solvent. So just grab a graduated cylinder. If you have a little stock of your solvent, you can just pour it in. If you're very close to 10, that is good enough. All right. Now that solvent can go right in the flask, and you can swirl it to mix. Like so. And if you're paying close attention, if you can see in the video, we've got two layers. Okay, the bottom one is yellow. The top has some solid. Okay, so once again, dichloromethane is dense. It's on the bottom. It became yellow. It dissolved something. Okay, so now we're going to transfer that mixture into the separatory funnel. All right. So plastic funnels are really useful for avoiding spills. Doesn't matter which one you use from your drawer. It could be glass, could be plastic. Get that ready. Okay, take your reaction mixture and pour it in. Now you can always use extra solvent to help rinse the flask. All right, so we're using dichloromethane for extractions. So I'm just going to grab a little pipette full, swirl it around, and add it in. I'm going to do a couple of those. All right. Okay, now you can see the two layers. Water on top, that was our original reaction solvent. Dichloromethane, the solvent that we've added to solubilize the product. Okay, we want to make sure that those layers have had a really good chance to mix. Okay, so here's what you do. Don't be afraid to be vigorous. You do want to do this in the hood. So lift it out, hold it firmly in your hand, put the stopper in, okay. And then you want to invert that and immediately vent away from you. Did you hear that hiss? All right, that lets out the pressure. Then you shake it and vent it. And do that 2 more times for a total of 3. Think about making salad dressing, really mixing the oil and the water. All right, so I did 3 times, vented it between. Now I'm going to set that separatory funnel back up, take the stopper out, and just set that down. Okay. Now we do have 2 clear layers. If you saw tons and tons of bubbles, you can gently side swirl, as I'm doing right now, until they settle and you see a clear interface. And what I mean by that is a line. Okay, when you're convinced that you can tell where one layer stops and the other starts, then you're ready to separate them. And I am now. All right. So there should be plenty of tape in the lab for labeling. Don't be afraid to use it. I'm going to label the beaker underneath. Once again, dichloromethane is more dense than water. It is on the bottom. It's the organic solvent, so I'm going to call this the organic. And for good measure, I'm going to call it the bottom layer. Good labeling can help you troubleshoot if you get confused or did something wrong. All right, now let me show you how to separate. You can either bring this closer so the splashes don't get out of the flask, or I could have held the beaker up. Okay. Okay, now remember, when you open the stopcock, the hole aligns. I have a bubble down there, so I'm going to swirl it. There, I think it went to the top. Okay. All right, I'm going to gently open the stopcock. And as it's close to straight up and down, you see drops coming down. Now it goes faster if I line it all the way up. So it's fine to go fast in the beginning, but as the interface approaches the bottom, you want to cut it off and go like much slower. All right, so the goal is to close the stopcock when that interface approaches the holes. If you were to miss it, no problem. You could always pour the whole thing back in the top and redo it. Okay, so it looks like I have a little yellow bubble at the bottom. There we go. Alright, so the top layer is in the separatory funnel, the bottom layer is in the beaker. If you were instructed to fully separate those layers, we could remove this beaker and replace it with a clean one to collect the top. However, with extractions, we often are going to see if we have any organic products stuck in the top layer, the water solvent. There shouldn't be much at this point, but if there is, we're going to give it a second chance with fresh solvent. All right. So I have my fresh dichloromethane. I'm going to measure out another 10 mils. Again, quantities are usually given to you in a procedure. I'm going to add this right into the separatory funnel. As I did so, I got a second layer. Okay, but it's not going to do much for me until I mix those. So here we go. Take this out, put the stopper in. Okay, I'm going to grab this, invert it while holding the stopper in, and vent it. Then I'm going to shake, vent, shake, vent, shake, and vent. Okay, I'm going to let those layers settle. Take the stopcock out. Okay, once again, I've got a nice clear interface already. And again, the organic solvent is on the bottom. This is my second chance. If it pulled out any remaining organic product, it's going to be in the bottom layer. So I'm just going to drain it into that original beaker. And after this, I should have achieved an extraction of the product into the dichloromethane, leaving behind water with any byproducts that the water solubilizes, like salt, inorganic salts. Okay. So that's extraction. Now my organic product is an organic solvent and solubilized.